I like to just start off, we've looked at a cubic meter, and so I'll ask the kids to hold up fingers. So I'm going to pour this liquid into this graduated cylinder. It graduated last year, right? I'm going to pour it in there, and how many times is it going to fill it, right? Is it going to fill it, let's say 10 tenths? Is it going to fill it only 9 tenths full, 8 tenths, 7 tenths, 6 tenths, 5 tenths? Is it going to fill it halfway, right? Right? So I have all the kids predict, right? You always have to give the kids a chance to predict, right? And then you pour it in. And of course, this is a smart water bottle. It holds a liter of water. It's the official water bottle of the Pacific Crest Trail. And of course, the answer is that it fills it 10 tenths of the way full, because this is a liter, that's a liter, right? And then I tell the kids, I say, okay, I've got this cube here. What I'm going to do is I've got a beaker right here, okay, a beaker. And you always have to be credible, right? I'm going to pour this in there, and when it gets full, I'm going to pour it out, right? How many times is it going to fill that? Is it going to fill it once, twice? Have them predict. 3 times, 4 times, 5 times, right? Okay, and usually it's like 2, but I get kids, it's going to fill it 5 times, right? And then, with enthusiasm, you can pour that in there, right? It's like, whoa, look at that, baby. And of course, it's like, right? And then, you say, well, how many milliliters is a liter? Well, it's 1,000 milliliters, right? So how many cubic centimeters is that? Well, eventually they'll remember that it's 1,000 cubic centimeters. So what does this measure, right? Oh, it measures 10 by 10 by 10. It's a liter, right? Okay. And I used to, back when I taught physical science, I used to actually have kids do something called estimetrics, where they would, on a piece of paper, write down an estimation, like what is the width of this in centimeters? And they'd write it down on a piece of paper, not show anybody. And then the kids would all measure it, right? And whoever got the closest would get the most points, right? They'd get as many points as the people that they beat, right? Then you could do that with length, and the kids have to agree on how to measure length, and you can do it with mass, right? Like, what's the mass of these things? And then they have to mass it on a triple beam balance or a precision scale or something like that, right? And they get really good at estimating masses and lengths, right? You could do it with time intervals somehow if you had like an interval timer, right? But the most impressive was we'd do volume, right? What's the volume? And you could do volumes of solid objects, right? So they have to do displacement. You could do volume of containers, right? And then they have to agree on how to measure it with a graduated cylinder. And they got really good at that. I mean, you would not fool my 9th graders with this. They'd be spot on. They'd get, easily within 5%.